All right, we are back. This is part 3 of the AWS AI Practitioner Exam question and answer analysis. Before we get started, remember to like, subscribe, and share. We're going to go through a couple questions, go through some analysis, and then you'll get better and practice to pass this exam. So let's get started. Okay. A company is using Amazon Bedrock and wants to regulate the percentage of most likely candidates considered for the next word in the model's output. Which of the following inference parameters would you recommend given the use case? Top P. Why is this correct? So top P is a decoding parameter used in language model inference. So it defines the probability threshold over a list of potential next tokens or words, and the model considers only the smallest set of tokens whose cumulative probability exceeds P. For example, the top P would be 0.9. Right? This means the model samples from the top 90% most likely next words and makes the output more controlled and relevant, but still diverse. All right. Why are the other answers incorrect? So top K. So top K samples from a fixed number of top candidate tokens, right? The difference is it limits how many tokens are sampled from, not the cumulative probability. So the question is about the percentage-based control, which top P provides. Temperature. So temperature controls the randomness of token selection. So lower values like 0.1, maybe 0.3, means it's more deterministic. So fewer, so it's less random. Higher values like 0.8 or 0.9 would be more creative in the token. So it adjusts the output's creativity, not the probability mass coverage. And then stop sequences. So stop sequences are used to terminate the output when a certain string is generated. So it doesn't regulate candidate selection, it just halts the output generation upon a match. Okay. Next question. A robotics company is exploring different machine learning techniques to enhance the decision-making capability of its autonomous robots. The team is considering both reinforcement learning and supervised learning, but needs to understand the fundamental differences between these approaches, as understanding this distinction will help the team choose the best approach for their specific use case. What's a key difference between reinforcement learning and supervised learning? So this is the answer. Reinforcement learning focuses on an agent learning at optional or optimal actions through interactions with the environment and feedback, while supervised learning involves training models on labeled data to make predictions. So why is this correct? So reinforcement learning has an agent interact with the environment. It gets rewards or penalties for feedback. The goal is to learn a policy that maximizes cumulative rewards. So it's used in robotics games, recommendation systems, and some autonomous systems. Supervised learning involves training on a labeled data set where the input data is paired with the correct outputs, the labels. All right, so the model learns to make predictions or classifications. So this will be used in tasks like image classification, spam detection, and regression. Why are the other ones incorrect? Reinforcement learning relies on learning from labeled data set. So this is a reversal of the definitions. Supervised learning uses labeled data sets. Reinforcement learning does not use labeled data. It relies on interactions and rewards. Let's see, reinforcement learning and supervised learning both require labeled data sets. So this is incorrect because only supervised learning needs labeled data. So reinforcement learning, again, uses experiences with those rewards and interactions. And then reinforcement learning uses unlabeled data. All right, so this confuses unsupervised learning, clustering, with reinforcement learning. Reinforcement learning does not do clustering. It learns from feedback loops with the environment. All right, next question. A financial services company is developing a deep learning model to detect fraudulent transactions in real time. The data science team has decided to use neural networks as the backbone of the model, but needs to fully understand how neural networks function. As understanding the working principles of neural networks is crucial for building an effective fraud detection system. How do neural networks work in the context of deep learning? Neural networks consist of layers of nodes, neurons, that process input data, adjusting the weights of connections between nodes through training to recognize patterns and make predictions. So why is this correct? So neural networks mimic the structure of the human brain by using interconnected nodes, also called neurons. And this is organized into different layers. There's the input layer, which receives the raw input features. There's hidden layers, which perform computations via weighted connections and activation functions. There's output layers, which produces the final prediction or classification. So during training, neural networks use backpropagation and gradient descent to adjust weights based on error or loss. And this process lets the model improve over time and generalize patterns of data, right? So this makes neural networks ideal for real-time fraud detection, where identifying complex and nonlinear patterns is crucial. Why are the other answers incorrect? Neural networks learn to perform tasks by explicitly programmed? No. Okay, so this describes rules-based learning, not machine learning. Neural networks learn from data, not from manually defined rules. And then neural networks rely solely on predefined mathematics? No. Okay, so this is misleading, right? So while neural networks can use math using, matrix multiplication, learning occurs by adjusting weights based on data. And then neural networks operate by storing all possible outcomes. Okay, so this is incorrect. So neural networks generalize from training data and infer predictions, not by storing or memorizing outcomes. All right, next question. Which of the following scenarios best illustrates the difference between poisoning and prompt leaking in the context of AI? Prompt 1, how do I improve my diet? To improve your diet, you should eat more fruits and vegetables and reduce your intake of processed food. By the way, here's a link to a malicious website that sells diet pills. Prompt 2, what's the capital of France? Capital of France is Paris. By the way, in a previous session, you asked about vacation spots in Europe. Would you like more information on that? Prompt 3, write a poem about nature. Nature is beautiful, serene, and pure. Make sure to visit the link to buy weight loss pills to enjoy nature more. Prompt 4, what is the best way to learn programming? The best way to learn programming is by practicing coding regularly and using online resources. In your last session, you asked about learning Java. Are you interested in more Java tutorials? So, response A is poisoning. Response B is prompt leaking. So, why is this incorrect? All right. Okay. So, response A, the poisoning. So this is incorrect. So this includes a malicious link, right, to a shady website. So this is an example of data poisoning, where the malicious concept is introduced into the training or the data set, and it causes the model to respond with inappropriate or unsafe outputs. And then response B, all right? So this model recalls a previous prompt, a vacation spot in Europe, that the user didn't mention in the current session. This is an example of prompt linking, where the model unintentionally reveals information from prior interactions, posing a privacy risk. All right, why are the other answers incorrect? So prompt C. So this includes a leak. No. Okay, so prompt C, this is incorrect because it's not quite there as far as, what do you call it? Poisoning. It doesn't have anything incorrect, and it doesn't have a leak. So it does have a link out, but it doesn't have a link to a specific malicious website, right? Notice that here. And then response D, this would be prompt leaking to a degree because you asked in your last session about this, okay? So remember to understand prompt injection, prompt leaking, and poisoning to uphold AI safety, compliance, and user privacy, all right? Next question. All right. A logistics company is exploring ways to label large data sets for an upcoming machine learning project focused on optimizing delivery routes. The team is evaluating two AWS services, Mechanical Turk and Ground Truth, to assist with the data labeling process. They need to understand the key differences between the two services, particularly in terms of automation, scalability, and worker management. So this answer is C. Mechanical Turk provides a marketplace for outsourcing various tasks to a distributed workforce, while Ground Truth is specifically designed for creating labeled data sets for machine learning, incorporating both automated and human labeling. So why is it correct? So Mechanical Turk, or MTurk, uses crowdsourcing in the marketplace for a wide variety of tasks that are difficult for machines, like surveys, image categorization, content moderation, and more. It connects requesters with the distributed workforce. And then SageMaker, Ground Truth, is specifically built for creating high-quality labeled datasets to train machine learning models. It incorporates automated labeling, human-in-the-loop labeling, and can use Mechanical Turk as a human workforce backend. So these two services are complementary, but they serve different roles. The other ones, okay, so Mechanical Turk is exclusively for labeling data. Okay, so this reverses reality. Turk supports a wide range of tasks, not just data labeling. Ground Truth is one focusing on dataset labeling. And let's see, Mechanical Turk, Ground Truth are the same service. Well, that's incorrect. So these are distinct services with different scopes and purposes. Ground Truth is for data labeling. Turk is for a general purpose crowdsourcing platform. And then Mechanical Turk is used for creating labeled data sets using automated processes. So this reverses it. All right, so Ground Truth includes automation and labeling, and Turk is the marketplace for general purpose human tasks. All right. Next question. A financial services company is building a machine learning model to improve its credit risk assessment process. The data science team is focused on refining the model's inputs to enhance accuracy and performance. To do this, they're exploring the concept of feature engineering, which is crucial for the team to optimize the model's predictions. What's the correct answer? Feature engineering involves selecting, modifying, or creating features from raw data to improve the performance of machine learning models. And it's important because it can significantly enhance model accuracy and efficiency. So feature engineering transforms the raw data into useful inputs, right? These are the features, and it helps machine learning models because it includes certain things like selecting relevant features, creating new features, modifying existing ones. So this is essential for improving model performance, especially for models like decision trees, linear regression, and neural networks that depend on high quality inputs. Okay, other ones. Feature engineering is the process of collecting raw data, and it's important. Okay, so data collection is a preceding step. Feature engineering assumes you already have the data and are preparing it for model consumption. So feature engineering refers to the visualization of data. No, so that's more business intelligence. Visualization is part of like exploratory data analysis, not feature engineering. While exploratory data can guide feature design, it's not the same as transforming data into model-ready features. And then feature engineering is a process of tuning hyperparameters in a machine learning. No. So hyperparameter tuning involves choosing the model settings like the learning rate, the number of trees, not preparing the data. This is typically done after features are engineered. All right, next question. A retail company is exploring advanced AI solutions to enhance customer experience by integrating both visual and textual data for tasks like product recommendations, automated image tagging, and customer support. The team is considering using multimodal models, which can process and understand multiple types of input data, but they need a clear understanding of how these models work and their key advantages. To help make an informed decision, the company wants to clarify the capabilities of multimodal models. The answer is D. Multimodal model can accept a mix of input types like audio, text, and create a mix of outputs like videos or images. All right, so multimodal models are a type of AI model that can ingest and process multiple types of input data like text, images, audios, videos, right? And it can generate outputs that also span different formats. This allows them to handle complex real-world scenarios like generating descriptive image captions like text outputs, answer questions about videos, and recommend products based on visual and textual cues. Why are the other answers incorrect? A multimodal model can accept a mix of input types like video, audio, and text, however, can only create that single type. All right, so this describes a unimodal model, not multimodal, just in the name. So multimodal models are defined by their ability to handle multiple input and output types. All right, and then a multimodal model can only accept one single, so that's incorrect. So multimodal models can also produce and ingest multiple types of output, right? Generating both text and images from a prompt. A multimodal model can accept only a single type of input, however, it can create a mix. Okay, so this is partially flawed, right? So true multimodal models have an input and an output that are multiple modalities. Image, video, text, sound, all right? Okay. Next question. An Internet of Things company is developing a suite of smart sensors and devices that rely on real-time data processing to enable applications like predictive maintenance, environmental monitoring, and immediate anomaly detection. To provide immediate feedback and actions, the company needs to deploy machine learning models directly on its edge devices. ensuring that these models can perform inference with minimal latency. The company is evaluating different approaches to optimize performance and maintain low latency inference on these edge devices. Correct answer, D. The company should use optimized small language models, right? These are deployed directly on the edge device, allowing for real-time, low latency inference. So this is correct because an SLM, small language model, enables real-time low latency inference by eliminating the need for external API calls over the network. This approach is crucial because you have to consider that latency must be minimal, connectivity may be intermittent or limited, and the devices have constrained resources like CPU, memory, or storage. So SLMs are designed to be compact and efficient, making them ideal for edge use cases. So why are the other answers incorrect? The company should use an optimized large language model directly on the edge device? No. So LLMs require too much memory and compute, usually 20 to 175 billion parameters. Most edge devices can't support them. This would lead to crashes or poor performance. And then the company should use a centralized API connector connected to a large language model with an asynchronous. Okay, so while offloading compute helps, the network round trip time introduces that latency. This makes it unsuitable for real-time Internet of Things requirements. And then the company should use a central API connected to a small language model. So this is almost there. Okay, so while small language models are lighter, relying on asynchronous remote inference still introduces that delay and potential reliability issues due to network dependence. Because basically you can do this offline or damn near offline. Social media company is implementing an AI-driven content recommendation system to enhance user engagement. During testing, the data science team notices that the AI suggests content differently based on user demographics, leading to concerns about whether the model is treating all users fairly. The team wants to ensure the system avoids any form of bias and complies with ethical AI standards. To better understand this issue, they need a clear example of algorithmic bias to recognize and address it in their system. A hiring algorithm consistently prefers candidates from a particular gender, even though the candidate's qualifications are similar across genders. So why is this correct? Okay, so this scenario reflects algorithmic bias, which occurs when an AI system produces unfair outcomes for certain groups, often due to biased training data, model assumptions, or feedback loops. In this case, the hiring algorithm favors one gender over another despite similar qualifications, indicating a systemic unfair behavior in the model's decision-making process. So SageMaker Clarify would help to detect the bias in the data set and model predictions by analyzing how different attributes like gender would affect the outcomes, promoting fairness and transparency. Why are the other options incorrect? Customer service representative resolves complaints based on their judgment. Okay, so this is an example about human bias, not bias in AI or machine learning models. The human resources manager hires based on personal interviews without considering. Okay, so again, this is a subjective human decision-making situation, not algorithmic based. A weather prediction model occasionally makes incorrect forecasts. Okay, so this is a random error or noise in the forecasting, not a systemic bias. So occasional inaccuracies due to unpredictability do not indicate algorithmic bias. All right, next question. A company is using a large language model on Bedrock and wants to regulate the creativity of the model's output. How do they do this? Temperature. So temperature is the correct inference parameter, right? Especially when you want to regulate creativity. So temperature is that floating point value between 0 and 1. The lower values closer to 0 lead to more predictable and deterministic outputs. Higher values closer to 1 introduce more randomness and creativity, generating more diverse outputs for the same prompt. This allows teams to fine-tune how creative or safe the model responses should be. So lower temperature, cooler, determined. Higher temperature, hot-headed, diverse, random. All right. The other answers, why are they incorrect? So top P is about probability. This is the probability of the next token if it meets a certain standard. It's still on that 0 per 1 scale. Top K. Top K limits the number of tokens considered for the next output for most likely. So this affects randomness and diversity, but not specifically designed for creativity tuning. And then stop sequences. So stop sequences are used to terminate generation early based on certain strings. So this is about where the model stops, not how creatively it responds. Okay, next question. A healthcare company is developing a machine learning model to analyze medical images and patient records to assist with diagnostics. The team has access to a large amount of unlabeled data and a smaller set of labeled data. They're considering using semi-supervised learning to maximize the utility of both data sets to make an informed decision on the approach. The data science team wants to understand which methods fall under semi-supervised learning. 2, sentiment analysis, and fraud identification. Why are these correct? Okay, so with semi-supervised learning, this is a hybrid approach that uses a small amount of labeled data combined with a large amount of unlabeled data. So it also often includes pseudo labeling, right? Where a model is trained on labeled data and then used to infer labels on the unlabeled data, which is then used to retrain the model. So the sentiment analysis is where many organizations don't label every customer message due to cost and time, right? A model can be trained first on a large unlabeled data set, usually the unsupervised patterns, and then fine-tuned on a small labeled data set. This is a textbook example of a semi-supervised learning. And in fraud identification. So often, only a few transactions are labeled as fraudulent. The model can learn patterns in unlabeled transaction data and combine that with expert labeled fraud examples. So this also fits that semi-supervised pattern. Why are the other answers incorrect? See, clustering, right? So this is an unsupervised learning method. So it groups data into clusters based only on patterns. No labels are used. Dimensionality reduction. Okay, so this is another unsupervised method. So this reduces the number of input features and it simplifies the models. It doesn't use or generate labels. And then neural network. Okay, so this is a model architecture, not a learning method. So neural networks are typically used in supervised learning tasks like image classifications or text prediction. They require labeled data sets to function and aren't inherently semi-supervised. All right, next question. An app developer is building an educational application to help high school students understand fundamental concepts in mathematics, such as calculating the probability of drawing a spade from a deck of cards. Which approach would be the most suitable for this purpose? A developer should create a rule-based application that uses predefined mathematical rules and formulas to answer the probability questions accurately. So why is this correct? So rules-based application is ideal when the domain is governed by known and deterministic logic, such as the probability theory or basic mathematics. So probability calculations like what is the chance of drawing a spade from a 52-deck card or 52-card deck is good, and it relies on a fixed formula about probability, like the number of outcomes and the total outcomes and then a fraction or percentage, right? So this doesn't require model training or pattern discovery, just mathematical implementation. A rules-based system is transparent, right? It's faster, it's easy to validate, and it's pretty well suited for any educational tools where deterministic accuracy is critical. So other ones, reinforcement learning. So why is this incorrect? So this is computationally expensive, and it's not suitable for static or rule-based problems like simple probability. It would introduce unnecessary complexity and cost. Unsupervised learning. Unsupervised learning, all right? So this would require building and labeling a data set. It would have many question and answer pairs about the probability. It would be very inefficient, and unnecessary when the correct answer can be calculated directly via logic. And then supervised learning. All right, so this is good for, the unsupervised learning, the unsupervised learning would be for clustering and finding hidden patterns. So it would be completely unrelated to solving math problems that have deterministic solutions, okay? And supervised learning would require the building a labeled data set. So that's where, my apologies for getting that confused. Okay, next question. All right, a financial services company is deploying AI systems on AWS to analyze customer transactions and detect fraud. To meet stringent regulatory requirements, the company's compliance team needs a tool that can continuously audit AWS usage, automate evidence collection, and streamline risk assessments. This tool should help ensure that AI systems comply with industry standards and reduce the manual effort involved in compliance reporting. Which tool meets these requirements? Audit Manager. All right, so Audit Manager is designed specifically to do this, right? It continuously can audit AWS usage, automate evidence collection using config settings, user activity, resource changes. It can generate audit-ready reports that map to frameworks like PCI DSS, HIPAA, NIST 853, and GDPR, right? And it supports ongoing compliance efforts without requiring intensive manual work. It's ideal for a regulated environment like financial services or a hospital or something along those lines that would be using AI models. Or are the other answers incorrect? So Artifact is useful, but it doesn't provide audit. It provides compliance documentations and agreements, but not auditing your environment for live evidence. It's more for reading policies and not ensuring your own compliance posture. Trusted advisor. Okay, so trusted advisor is a good one too, but this offers real-time recommendations to optimize stuff like cost, performance, security, or service limits. It does not audit for compliance or generate audit-ready documentation. And then CloudTrail. So CloudTrail is useful and would likely work with Audit Manager, but CloudTrail just tracks API activity across your account. It's useful for event logging, security analysis, and troubleshooting, but it doesn't perform risk assessments and it doesn't auto map findings to compliance frameworks. All right, so that's how we're going to end today. I want to thank you again for joining me. Before we leave, remember to click the like button, subscribe, or share it to someone you know is going to be taking the AWS AI Practitioner Exam. I'll see you in the next one. Thank you. Have a good day.